So, welcome to the introductory session on Python for Data Science. This is Dr. Kusuma, Assistant Professor, Head of the Department, Data Science. These are the contents I'll be delivering in the today's session. Firstly, I'll be beginning with what is data science life cycle, and next I'll move on to Python for Data Science, why it is required, Python data science libraries, and I'll take you to the Pandas. So before beginning today's course, you should have some prior experience with Jupyter Notebooks, Colab, and a basic understanding of Python programming. So the learning outcomes from this particular course is what is data science and how it is used in the different areas, and how we are going to explore the diverse area of career opportunities within data science and identify the essential skill required for success in each role. Learn how to use Python and Pandas, an important tool for managing data effectively. Let's start how this data science is evolved. As we all know this, in recent years, big data has become a buzzword, and more efficient ways to store data become a major challenge. So the company started investing in big data focused on developing frameworks capable of handling vast amount of information. And this led to the creation of platforms like Hadoop, which facilitated the storage of massive dataset. But the storage challenges were solved and sorted out. But attention turned to processing and analyzing the stored data. This is where data science emerged as a crucial tool for handling and interpreting data. So, what is data science? Data science is a field that involves extracting insights and knowledge from data, typically using a combination of statistics, machine learning, and computer science techniques. Let me tell you in a simple way of what is data science. I'll just take one Excel sheet. I'll create some data. Student data S1, S2, isolation S3, S4. Some students' data I'm taking here. I'll be taking two columns for mid marks and mid 2 marks. So what I'll be doing here, I'll be just giving some random marks values. So we'll just do some interpretation by drawing the bar graph over here. So what we can get some insight on this particular graph in the sense that each and every student, like few students performed well in the mid 2 and few students performed well in the mid 1. But when we take an overall percentage, like mid 1 is better compared to the mid 2. So we can identify what was the problem, why students were not able to perform well in any of the assessment. So this type of insights we can easily get from the graphs. So this is what actually the data science. We'll have some data and we'll do some interpretation and we'll get some insights from that particular data. This is what in a simple way I can tell what is data science. But here I have taken only few number of student samples. When I have like more number of samples, what happens in the sense, Excel stops working. So that is where we are going to use an data science tool to work on huge number of data to clean, analyze, and interpret data to solve complex problems and to gain a deeper understanding of a particular data what we have taken. So coming to the data science life cycle, there are 7 important steps followed in the data science life cycle. First, we should have some problem, and based on that problem, we are going to collect the data required to that particular scenario. Once the data is we collected, next we are going to clean the data, in the sense we are going to eliminate the duplicates and we are going to eliminate the null values. Why? Because the duplicates and null values will never give any important information when we are going to do some interpretation. So we wanted to clean the data. Next, after that, we are going to do some analysis on that particular data. Next, we'll go with then feature engineering. What are the important features we require to do some interpretation? When there are like many features are available, when few features are not giving any meaning to that particular model which I'm going to generate. In that case, I can eliminate those features from that particular data. Next, we can also implement we are going to use the data to implement by using and to train the model by using a machine learning or deep learning algorithm. Then we are going to do the model evaluation. Finally, where we are going to do the data visualization. So these are the important steps involved in the data science life cycle. So to become a data scientist or to become a data analyst, we should be familiar with all these 7 steps. First, initially, we're going to go with an problem identification, collecting the data, cleaning, exploring the data, processing the feature engineering, and familiar with machine learning and deep learning, evaluating how to evaluate the model, and finally, we're going to do an data visualization. So next, what are the like now in 21st century, the most demanding job is data scientist job. So what are the different jobs available in the market? Those are very familiar with the data science skills. The first is like data scientist, data engineer, business analyst, data architect, data analyst, AI engineer, machine learning engineer, statistician, BI analyst, NLP engineer, like many roles we are having when we are familiar with the data science. So nowadays, the data scientists are get earning more compared to the other software engineers. So to become any one of this or to secure any of one of this job, what are the skills we require? So the important skills we required is first we should be familiar with any of the programming language, and we should be familiar with the statistics and math and how to work with a database like SQL or no SQL. We should be familiar with the database management system. Next, we should also have a good sound knowledge on deep learning and big data knowledge, how to store and process the data, how we are going to report some of the tools, how we are going to do the visualization tools or reporting tools, and finally, like model deployment and how we are going to use the cloud services to store and extract the data. So these are the skills, very important skills required to become a data scientist. So if you're good at all these skills, then we can easily get a job as a data scientist or data analyst or data engineer, or whatever might be the role related to the data science. So why like Python is chosen for the data science? Because the Python is very easy, general purpose, high level programming language, and it is used among the developers community. And it is like what are the important features like easy, interpreted, object oriented, free and open source, portable, and it also supports for the GUI programming language, and also it have the large set of Python library. So this is where like the data science for all the reporting tools and to generate some visualization, the Python has become most popular. So, like in this particular course, Python for data science, we will be learning in each session about the different data science libraries like Pandas, NumPy, Scikit, Matplotlib, Seaborn, and PyCaret. So, in the today's session, I'll be giving an overview of what is Pandas, how to use Pandas, and how we are going to clean the data by using the Pandas library. So let's start with Pandas. Pandas is a Python library for working with data science. It has functions for analyzing, cleaning, exploring, and manipulating data. So before load training the model for any machine learning by any algorithms, machine learning or deep learning, we should clean the data. Then only we can do some proper interpretation on the data. So that is where first we are going to start working with the pandas. We are going to load the data with pandas. We're going to clean, explore, and manipulate the data. Next, we'll load the data into the training model. So the name pandas has a reference to both panel data and Python data analysis and was created by Wes McKinney in 2008. So pandas allows us to analyze big data and make conclusions based on statistical theories. And also it clean messy data sets and make them readable and relevant. And also it will delete the duplicate rows and which contains the null values and which are not relevant, which contains wrong values, empty, null, everything we can clean by using the pandas library. So let's see how we are going to work with pandas. Before that, as I told you, you should have some prior knowledge on Google Colab or Jupyter Notebook and also Python programming language. So if you have some good knowledge on it, we can easily understand how we are going to use pandas in the data science. So let me take you to the Colab. So this is just I'm using for the Colab. So here, just renaming I've taken the new notebook. I'm just renaming it to Pandas because we are working on Pandas today. So first, we need to install the Pandas library. How we are going to install in the sense we are going to use an preferred installer program, that is PIP. So PIP install Pandas. Let me run this particular cell. So once it is installed, we can easily import that Pandas to work for the program. So it is taking some time to install. So once it is done, what we are going to do in the sense, we are going to import Pandas. So when import Pandas is successful, then we can see that the Pandas installed perfectly in this notebook. So now I'll be importing the library Panda, import Pandas. So many times what I'll be using in the sense, the name Pandas I'll be using in the code. So calling Pandas is like a little bit big. So I wanted to give a nickname for the Pandas. Or we can also give some short name by using an alias command. So how are we going to use it in the sense? Import Pandas as PD. This is what, and as is an alias command, what we have done here in the sense, PD have given for the Pandas as a short name. Now I can use wherever I'm going to use in Pandas, I can use an PD command, PD as a short name. So next you can also check the version of Pandas by using an, we know that only the print statement is the output command we're having in the Python. So print PD version. So we can check the version which we have installed now. The latest version is like 1.5.3 we have installed in our notebook now. So next, very importantly, we're having two data structures. One is in series data structure and one more is in data frame data structures we are using in the Pandas. Series is a one-dimensional array and data frame is a two-dimensional array. So let's see one by one with an example. First, series, as I told you, series is like a column in a table. It is a one-dimensional array. And Python here, whatever the commands we are using is a case sensitive. So how we are going to use the syntax for the series is pandas dot series of object. Object, whatever we are going to create a list of elements, might be an array or might be a tuple, whatever the thing. So here I'll be using a syntax pandas dot series to create a series for the given values. So let's see how we are going to create a series of values here. Again, I'm switching on to the Colab. So here you can observe how I'll be creating an object. I'll just create a list called A, 10, 20, 30, 40, some values. I'm just creating a list. So for this, I want to create a series. So for that, I'm using one more variable, B is equal to PD dot series. This is a capital series of A. I just print. You can observe it has been created and series in the sense the index value is given to the each and every row like 0, 1, 2, 3, 4. Like this a series we have created and this is a one dimensional array. So only one column will be available in this particular series. So next, if I wanted to go with the specific index, the default value what it is going to take in the sense it will start from the 0. Now what I wanted to do, I wanted to create some index value which I prefer. So what I'll be doing, I'll be using an index method. So that again, I'll be using a variable called as an dot series. This is a capital series A comma A is where I have used a particular object A comma index is equal to, you can use single or double quotation. So how many values I'm having? 5 values. For that each and every value, I'll be giving a text name here. So I'll be using ABCD. Now I'll just print. You can see in the output, we have given our own index value for the each and every a row. So previously the default value it has taken like 0, 1, 2, 3, 4. Now what we have done, I've just given my own index value for each and every row. A is for 10, B is for 20, C is for 30, D is for 40, and E is for 50. So like this we can create an object, and we can use, and we can also create an index name for each and every row. And there is another way also to create an series by using a dictionary. So let's also work it out to create a dictionary and to create a series for the dictionary. So I'll just create one dictionary here. I'll just take one. I'll just take something like one key value pair. As we all know that dictionary is consists of a key as well as a value pair. Key is day one I'm taking, and value have be taking one, and similarly date, and again I'll be giving the value 2. I'll take day 3, and for this day 3 I'll be assigning the value. So now created an a dictionary here. Once I run this dictionary, once I print this particular dictionary, you can see the values will be in the key value pair like day 1, day 2, day 3. Suppose if I wanted to create a series for this particular dictionary, again I'll be using a series command to create a series. So what I'll be doing here, I'll just go dot series of C. Now you can see it will be in the column wise, as well as in day 1 for the 1, day 2 for the 2, day 3 for the 3. So we can also create a series for the dictionary. This is one way of creating a series by using a dictionary, or for creating a giving some list of values and creating a series. So like this we'll be creating a series. So if I wanted to access a value from the series, so we can directly go with C of, I wanted to access day 1. The value of day 1 is 1. What is the key value here? Day 1. So what is the value for day 1 is 1. So like this we can print the value, and we can also access one by one key, as well as we can also access for this particular list also by giving an index value. See what I've done here in the previous case, I've created an index A, B, C, D. So if I wanted to access with the help of in that particular index value also, I can go print B of. So A is for the 10. We can see the output is 10. So we can access an element by using the index value, or else the default index values we are going to use 0, 1, 2, 3. Or if you have assigned some index names or index values to the particular values, then you can use that in all those index name to access the values. So this is about the series. Now let us understand the data frame. So what is a data frame? Data frame is a two-dimensional data structure. It consists of two-dimensional array or a table with rows and columns. Say Pandas data frame will be created by loading the data sets from existing storage or from the SQL database. It might consist of an CSV file, Excel file. A Pandas data frame can be created from list, dictionary, and from a list of dictionary also. Okay, so let us understand how we are going to create a data frame for the list, or how we are going to load the data by using an CSV file or Excel file. Let us see with an example. So I'll just create one more object called as an key, and I'll add some values 10, 20, as well as an. For this, I'll be creating a data frame. So what I'll be doing here, I'll just use an dot. Just pick how I'm using the syntax. E and F is a capital. Data frame key. I'll just print key. You can see it consists of print M. M is the data frame where I've created. You can see in the rows and column wise. The column is 0 and 0, 1, 2 are the row values. So this is what an two-dimensional array, where series is a single dimensional array, but data frame is a two-dimensional array. So next, let us take some more example how to create an index for the data frame. So I'll be just using again wanted to give some index name for every row rather than giving like 0, 1, 2. For that I'll be using m is equal to pd dot frame. So case object index is equal to, I'll just give d1, d2, d3. So let's execute this. Print. You can see the default values have been changed to the index names which I have given here. So day 1, day 2 as well as on day 3. Now this is how to work with a data frame. Just to understand what is data frame is a two-dimensional array. But actual job is here. We need to load the data set and we need to understand how we are going to clean the data or the data which we have loaded. So for that what I'll be doing, I'm just uploading one data set here. So this is how we are going to upload the data in the Colab. Just use this file icon, go to the files, and I wanted to upload this data here. So once it is done, I'll be loading this particular data into this Colab. See, here I have uploaded the data successfully. Now we will understand how to work with the data sets. So load CSV file. Okay. Load CSV file in the sense we are going to use and read CSV command. So I'll be using df is equal to Pandas. We have just used in pd read underscore CSV. So what is the file name uploaded here? Data.csv. Same file name we should use it. So data.csv. Let's print it. We can see the data, but here 169 rows and 4 columns are available. But the thing is only few data has been shown in the output console. So if I wanted to look the complete data in my output console, what I should use in this sense, I should use in toString. So print df string. Now you can see the complete data has been displayed in the console. If I don't use a toString, only it will show only the limited number of data. So if I use a toString, the whole data can be seen in the output console. See, from 0 to how many rows we are having? 169 rows and 4 columns. So the complete data can be seen in the output console. So let us do some analysis on this particular data. So the first thing, I'll be using some commands like head, tail, as well as how to what are the statistical commands we can use on that particular data. All those things, let us see it here. Suppose for the same data which I have uploaded, I'll be using df.head. You can see only the top 5 rows will be displayed in the output console. The same command, if I go with the 10, then top 10 values will be displayed in the output console. Similarly, if I wanted to check for the last rows of the values, then I can go with the tail command, that is print df.tail. We can see the last 5 rows in this particular output console. So this is how we'll be checking for the first 5 rows or the last 5 rows or how many rows you wanted to display by using the head or tail command. So next, what I'll be doing in the sense, I just wanted to know the complete mean, mode, max, min value from the dataset. For that, I'll be using and describe command. That is df.describe. So you can see in the output console like what is the total count in each and every column. So we have like 4 features in the particular dataset. One is in duration, pulse, max pulse, as well as in calories. So in each and every column, what is the total count of data we are having, and what is the mean of that particular column, standard deviation, and also min value, max value, and 25 percentile of the date value, and 50 percentile and 75 percentile of data can be seen in the with the help of the describe command. So we have like 169 data. We don't know like how many duplicates are there and how many null values are there. So our task is to clean the data. Then only we can load this data to train the model. So before training the model, we should remove all the duplicates, and also we should eliminate all the null values from that particular data set. So for that, what we'll be doing in the sense, I'll be using an dropna command. With the help of dropna, what I can do in the sense, wherever there is some null values, that can be eliminated. So just observe the syntax, what I'll be doing. So print df dot drop. Dropna is a method way to drop wherever the null values is available in that particular data set. So for that, I'll be using an in place is equal to. Why I'm using in place is equal to true in the sense, new data frame. Already we have the data frame with the which consists of in some null values. So what I need to do, I wanted to update that particular data set by removing all those particular null values. So for that particular reason only, we are going to use an in place is equal to true. If I don't use that in place is equal to true, what happens in the sense, we can observe that null value, but that will not be removed from that particular data set. So we should use an in place is equal to true to update with the new data frame. So now we'll see. I'll just run this. I'll just print. In this previous case, okay, print. Sorry, print. We can observe 164 entries. Okay, because in the previous case we have seen when I've used this particular head or tail, or when I print the DF, 169 rows and 4 columns were there. So now after using this drop, now wherever the null values are there, it has been removed. In now we can see 164 and it is re-updated within 164 entries. So similarly, what I can do in the sense, see the info command why I'm using in the sense to give the complete information for the data set. So what it is giving in the sense, how many rows are there, how many columns, okay, and how many null values are there, and what type of data in each and every particular data type like integer or float. The complete information will be given by using an info command. So next, similarly, what I'll be doing in the sense, I have some duplicates. I don't know whether I am having a duplicate in that particular data which I have uploaded. If I wanted to do it manually, what I should do, I should go and check each and every row, isn't it? So rather than that, I can use duplicate command to check for the duplicates. So for that, what I'll be doing in the sense, I'll be using a df. Okay. So now, after executing this, we can see that these are the rows like where we can find some duplicates. Okay. So now I wanted to drop those duplicates. I just identified the number of duplicates in this particular data set. Now I wanted to drop this particular rows from the data set. For that, we are going to use and drop now command. So df dot drop. Same thing, update the new data frame. I need to use an place is equal to. Let's run this command. So now again, I'll just check the info. We can see 157 entries. The earlier when we have taken this data set, it consists of 168 entries. After removing the null values, then 164 it is updated. Now after removing all the duplicate values, now our final data we are having like 157 entries. So this is how we are going to clean the data from the data set. So this is about an pandas what we have discussed series as well as an data frame. So this is how to read an CSV file. just now have shown with some example how we are going to load the CSV file and how we are going to clean the data, how we are going to remove the duplicates, and also how we are going to drop that particular duplicates from that particular data set. So this is how we work on that particular data set. So what are the methods we have seen in the today's session in the sense describe method, head method, tail, info, and cleaning data by removing the duplicates as well as by removing the null values from the data set. So this is about in Pandas. In the next session, I'll be taking to the NumPy. So first, in the NumPy also we can do some numerical methods by using a NumPy library. So in that session, we will understand by taking some example how the NumPy we're going to work on the data sets. So what's the final summary of this particular session is, so data science, as we all know that it is growing field that involves extracting insights and knowledge from large and complex data set. So we have understood the definition of data science, and we have also come across why Python we are using in the sense because Python is a popular programming language for data science due to its simplicity, versatility, and the availability of powerful libraries specifically designed for data analysis and visualization. And we have also understood the different data types and data science workflow and effective utilizing Python and its libraries in data science projects. And we come across the Pandas is a vital Python library for handling data. It offers structures like series and data frames for organized data management. With Pandas, why we are going to use Pandas? Because we wanted to clean, explore, and visualize data to become simple, making it essential for data scientists and analysts. So these are the reference which I've taken for covering this session.